Now we'll talk about the floating point types. They represent numbers with fractional parts, such as 43.32. Here, 33 supports three different sizes, the float, the double, and the long double. And this allows for varying precision levels. Usually, the size of the float is less than the double, is less than the long double. Just like integers, um, each type of a float has a different size or occupies a different size in the memory. And the common sizes used are like float is 4 bytes, which is 32 bits. Double is 8 bytes or 64. And long double is 10 bytes or 80 bits. And despite that, the size can also vary by machine. It can vary by machine itself. C++ includes other data types like bool, which holds values of either true or false, and string, which is a class type for handling text. And the string type must be defined with double quotes, and you need to include the string library to use it effectively in your program. Identifiers in C++ are names for variables, functions, classes, and structures. They are case sensitive and must start with the letter or an underscore. Subsequent characters can include letters, digits, and underscores, but identifiers cannot be keywords and must be unique within their scope. Keywords. Keywords in C++ are predefined terms that have special meanings in the language, and they appear in blue. Many IDEs avoid using these keywords as variable names to prevent confusion. Some important keywords include bool, car, false, float, short, and so on. In C++, a variable is a named region of memory used to store data. Before using a variable, you must define it, specifying its data type and name. Variable names are case sensitive, and examples include int dollars and double pi equal 3.14 15.9 and car begin equal a, and so on. So all these are examples of variables. Assignment in C++ involves assigning values to variables. You can assign literal values, like here, some ints equal 27. You can use expressions like sumdub equal 5.55 times 1.0, or assign values from other variables. There is so much flexibility, which allows for dynamic data manipulation. Multiple assignment and combined assignment. The assignment operator or the equal sign can be used multiple times in a single expression, such as here x equal y equal z equal 5. So this assigns the value 5 to z, then y, and finally x. And it's associating values from right to left. Comments. So these are really crucial for code documentation. In C++, you can write single line comments using 2 slashes, like here /name Brad Rip, or use multi-line comments enclosed in slash asterisk, and then you write your text and then asterisk slash. This is for more extensive notes. Comments. The purpose of comments is to clarify the code's purpose for you and for other programmers as well working on the same code. Rules for division. In C++, the behavior of division varies based on the data types involved. For example, dividing two doubles like 220.0 over 100.0 yields 2.2. However, dividing two integers such as 220 over 100 results in 2 because the decimal is discarded here. So when both the numerator and denominator are integers, the result is also an integer. When assigning values between different types, C++ performs automatic conversions. For instance, if you assign a decimal number to an int, it gets truncated. Conversely, assigning an int to a double converts it to a decimal. Like here, I equal yy. Oh, sorry here. This results in I being 2, while yy equal j. So this changes yy to 10.0. Let's see an example here. So if m is assigned 7 and n is assigned 2.5, the decimal 2.5 gets truncated to 2, and this happens when assigned to n. Then xx will receive the result of m over n, which is 3.0. Finally, we need to determine the new value of n after performing additional operations based on these conversions. Continuing from our example, after xx equal m over n is updated with the expression xx plus m over 2. This one. And the integer division m over 2 will result in 3, and then it's added to xx. It is treated as a double, yielding 6. Since n is an integer, the final value assigned to it is 6. Forcing a type change. You can explicitly change the type of an expression using a cast operation. The syntax is variable1 equal type, brackets, variable2. For example, double result1 equal x over y. This will give 0 over 0. Double result2 equal double x, double bracket x over y. This results in 0.5. So casting is really important because it allows for precise control over type conversions in your calculations. In C++, cin is the standard input stream. It uses the input operator, which is that one. It is used to extract data from the keyboard, and it automatically skips white space and converts it. It converts the input to the specified type, ensuring that only valid data is processed. And then this is the opposite. Is cout. Cout stream is used for output, and it uses or employs the output operator to send data to the screen. So you can, as in this example, you are prompting the user using cout. So you are displaying this, enter student ID and score, and then followed by reading using cin. You are getting the input with cin. Just checking if the meeting is still recording. Okay, yes, it's still recording. Okay. So C++ supports also special characters for formatting. For example, /t. This creates a tab space, while /n moves the cursor to a new line. These characters help structure output for better readability. To control output formatting, we include the iomanip. It's a library. And then we use the setw int size to specify the width of the output, and setPrecision int digit to control the number of significant digits. For instance, this one, cout fixed setPrecision of 2 formats numbers with 2 decimal places. This example demonstrates output formatting for lunch cost. So after prompting for input, the program calculates the cost per person and uses setPrecision to display the final output or the cost using the format that we want. So you can see here, I'm defining double cost of lunch, cost per person, and then integer number of people, just displaying a couple of sentences to the screen, to the user to give them some instructions. And then it takes the input, stores it in cost of lunch variable, and then displays another statement, and then takes in the number of people. And then the calculation is added, and then just some statements again. And then after that, the cost displays the cost per person at the end. So when the user inputs the cost of lunch here and the number of attendees, the program will compute and displays the cost per person. And the output is formatted to 2 decimal places, like here as in 88.97. Operators in C++ are symbols that perform operations on variables and values. They include arithmetic operations, comparison operators, and logical operators, each serving a specific purpose in programming. We have some logical, we'll see some logical operators here. We see the auto increment operator, the brackets. This one is used for indexing, the square brackets, the modulo sign, and so on. These are also additional operators, plus and minus, obviously, addition and subtraction. These are just for logical equalities and inequalities. And these are all logical operators used for conditions. So the first one, so maybe let's talk here about auto increment and decrement. So C++ allows for this operator for auto increment and decrement. So using, for example, j, like here, I equal j plus plus, this increases j by 1. Plus plus j does the same, but affects the variable immediately. So j plus plus, let's see this one, I equal j plus plus. So it will assign j to I first, and then increments the value of j. This one, it will increment first, and then assign the variable to I. Assign the new variable or new value to I. It works in different ways. Minus minus is the same concept, but decrements instead of increments. We can do also multiple assignments. So also this one is the conditional operator, which provides a shorthand way to express if-else logic. So this one, this first one. And we have also compound, we call it compound assignment operators like plus equal, minus equal, times equal, division equal, and so on. And this allows for concise arithmetic operations. So it is equivalent, let's say x plus equal y. This is equivalent to x equal x plus y. Arithmetic operators, just let me check it's still recording or not. Recording. Oh, it's not sharing. I'm really sorry. Arithmetic operators includes addition, subtraction, multiplication, and division, along with modulus to find remainders. And it follows the order of precedence, using usually the brackets or the parentheses have the highest priority. Multiplication, division, modulus, they have a second priority, and then the rest, which are addition, subtraction, and so on. The precedence, as I explained, the brackets here have the highest priority. So I have here m is multiplied by x first, grouped together, and we get the value, and then they are added to b. For the second one, x is added to b first, and then the result is multiplied by m, because the brackets are executed first. So usually the expression is evaluated from left to right with and the parentheses first, and then multiplication and division and modulus, followed by addition and subtraction. Relational operators, we compare two values to form conditions. They include equal, equal for equality, less than for less than, or greater, and then this greater than symbol for greater than, not equal. So if you are comparing two values and they are not equal, you want to check if they are not equal to each other. And they are useful in decisions, in writing decisions in your program. Also, operator precedence is crucial for predicting how expressions are evaluated. As I explained already, that multiplication and division take precedence over others. However, relational operators like greater than, smaller than are considered after arithmetic operations. So arithmetic operations are first, and then the relational ones. So you consider the expression, you can see here, y equal 2 times 5 plus 3 times 5 plus 7. So you would first calculate the multiplications from left to right. So these two 5s are multiplied together, and then 3 times 5 are multiplied. And then you go and start executing the additions from left to right. So you have here 2 times 5 equal 50 times, so this gives 50. And then you add it to whatever came from here, which is 15, and then plus 7. That's how it's executed. C++ is a free format language, meaning extra spaces and blank lines are ignored. You can format your code flexibly, allowing you to write multiple statements on one line or split a statement across several lines, making your code more readable. To enhance code readability, there are some rules. So, for example, you need to use descriptive headers, meaning that you use meaningful variable names. You need to comment each variable's purpose and keep executable statements on separate lines and document segments of code with comments to clarify functionality. And then usually a segment of code is, we call it the code block, like related statements. And it's also a good practice to use blank lines to separate segments of code. So that's a simple example of adding two numbers. It's just a dialogue between two people. Add illustrates. So here, the first person, which is Jim, prompts Sarah for two numbers, which are 2 and 5, and then calculates the sum, which is 7. This is just the basic interaction for performing arithmetic calculations in C++. And then the corresponding C++ code, which is asking the user for two numbers, calculates their sum, and displays the result. So you can see here it is just giving some instructions, which is exactly like the dialogue that was there, displaying the same statements, and then cin first. So after declaring the variables first, second, and sum, so it will take the input from the user and save it in first, and then take the input for the second value and save it here, and then do the addition, adds them together, and then outputs or displays the result as inside the sum variable on the screen. Just another example. So the purpose here is to write a program that converts the temperature from degrees Fahrenheit to Celsius. So this demonstrates the understanding of input handling. So for input, this program will take an integer input for the Fahrenheit temperature, and it will be used in the conversion formula to achieve the desired output. So we'll get input, do the calculation, and then output. And then the program will output a temperature in Celsius represented as a double or float. We can use either double or float for real numbers. Double is preferred for its large range, but if you are looking for memory efficiency, then you have to use float. So the formula for converting Fahrenheit to Celsius is Celsius equal 5/9 Fahrenheit minus 32. And this is crucial for accurately performing the temperature conversion in your program. And that's here a sample code for doing the conversion operation. This snippet illustrates the conversion. So first, it just declares an integer Fahrenheit and the double Celsius, just prompts the user for some instructions and takes the input, stores it in the Fahrenheit variable, and then I have here the calculation, converting from Fahrenheit to Celsius, and then displaying the output on the screen. A second problem or second example. So here you need to estimate the temperature in a freezer, giving the elapsed time. Elapsed time that happened or that took place since a power failure. So it should take the input from the users as number of hours and number of minutes. And there is a certain calculation to find the time based on the input from the user. And then it will take this time as an input to another equation. And it will just calculate the elapsed time based on that. You can see here the program will take two integer inputs. It will take hours and minutes. And the output here will be the estimated temperature in Celsius, represented as a double. And then the formula or relevant formula we'll use is that one. First, we calculate the total time using hours and minutes, and then we'll plug that into the temperature formula and to calculate the temperature. And this is actually a sample program. First, I define the integers, hours, and minutes, and then define two doubles, time and temperature, from the user to end the time. And then I take the time and store two values for hours and minutes, and then do the calculation for time and temperature, and then display on the screen. So today we cover just basic programs in C++. This was just a revision. And next time I would like to cover more on handling error and exceptions. So see you next time.